So, very warm welcome to our little online seminar today. To all participants, my name is Alfred Huber and I'm heading the technical department here at Softing IT Networks in Europe. And I will lead you today through this little webinar today. I'm not alone. Due to the high number of participants, we decided to share this job a little bit, and I think my colleague wants to introduce himself.
Sure. I'm Arda Kusholu. I'm product manager at Softing IT Networks, and I will be. Please ask your questions right away. Don't wait at the end of the presentation. I'll try to answer them already. If not, then we're gonna do it all in the Q&A session at the end of the presentation.
So let's start with the presentation. So the topic of today is PoE, some basics on the system itself, how it works, PoE, Ethernet, and the testing, influences of PoE on testing scenarios. So here again, the basics of remote power supply. So that is the nature of PoE, is remote powering terminal equipment, and very important, its effects on the cabling we are using to do that. So before we start to go into the technical details, some details on who we are. So who is Softing? A little brief introduction into this. So Softing is a Germany-based medium-sized company. It was founded in 1979 and went public in the year 2000. Last year's turnover was above 90 million euros, so best number all times. We are about 400 people in the whole organization, and we have local representations all over the world in various locations. Softing itself is, let's say, sits on 3 columns. So the columns on the left and the right is the automotive business. So these colleagues are doing, are designing solutions for diagnostics of ECUs in vehicles. So most prominent and major column we have. And on the right side, you see the industrial. Industrial means industrial automation. So these colleagues are taking care of products for industrial automation situations like gateways. They're also doing some data intelligence, collecting data of machines to maintenance before something goes wrong, definitely. So we are sitting in the middle a little bit. What are we doing? IT Networks is doing test and measurement equipment for networks, for Ethernet-based networks. So we are coming officially from the building environment. But in the meantime, Ethernet is moving into all directions, also into the industrial automation stuff. So wordings like Profinet are here, very famous. Also, Ethernet is going to move now into the automotive section. So cars will be controlled in the future via Ethernet. So all these different bus systems will be exchanged against Ethernet. Industrial environment, also the same technology trends. All these bus systems, existing serial bus system in the industrial automation, are being replaced, are going to be replaced sooner or later against Ethernet. And if Ethernet is moving into any application, it always brings its own cabling. And the testing of the cabling is pretty similar. Either it's a building or it's a car, or it's an industrial environment. So each time Ethernet is moving in, it also brings its cabling, and testing of the cabling is pretty similar. So this is why we're sitting here a little bit in the middle with our testing solutions to allow testing of Ethernet-based cabling. Where are we on the world, on the map? So you see the headquarters is where I'm just standing at the moment, is in Munich. We have also major representations and factories in Northern America, Knoxville, and on the east side, very famous office we have in Singapore, where our R&D sits for the high-end testing instrumentation. Also, other locations where we are is London, Paris, Milan, Vienna, and Shanghai. So sounds a little bit like the fashion area, but this is where the salespeople are located and doing the sales job all over the world. A few samples of instruments of our portfolio. So you can see here instruments appearing. So this is just a little commercial slide to give you a little glance at our instruments we are offering. So let's come back to PoE and what we're going to do. So what's the content of this little webinar today? So first of all, of course, what's the definition? What is Power over Ethernet? How is the definition? And where is it used? What are the fields of application? Then we're talking a little bit more in detail about the device types which are working in Power over Ethernet. What is the PSE? What is the PD? We are explaining what is mid-span, what is end-span, and the various modes and alternatives to drive PoE. What is 4-power PoE? So standardization, a very important factor. So if you do something like PoE, you need some basics, some fundament on this, and this is the standardization. What are the different standards? What is the evolution of the standards? We will look at some details in the standards, limits, values, and what we also do a little look is to the activation and classification procedure, which you need when you're doing a communication between two instruments. Then we're talking about the implementation of PoE, a little word on bundling of cables, which is getting very interesting now, because bundling of cables can be a risk in the PoE environment, but we will see what the background is. Some interaction between the cabling and the power which is transmitted on it. Requirements for smooth operation, how to make sure that PoE can coexist very nicely with data on the same cables. Then we look into the cabling requirements, and we'll have a look to some passive measurement, which is important to get some proper transmitted PoE and what are the basics here. Then active testing, the activation process, is it working? The switch is already installed in the network. Does this port where I'm sitting, does it work with PoE? So that's the content of this online seminar today. So let's start up. What is the definition of PoE? There is a lot of words you can describe what is PoE doing. But it's very simply it's doing a power sourcing of a terminal instrument together with data. So you're using the data line as the power line as well for the remote unit on the other side, on the end of a data link. And there are some common techniques for this power transmission over the Ethernet cabling. There is this mode A and mode B. We will explain a bit later. And there's also the newer development of PoE. It's the 4-pair Power over Ethernet, which is increasing the power you can draw from the source to drive lightning and so on. Okay, there is a defined signaling between the power supplier, which is called the PSE, we'll see in a minute, and the energy consumer, which is called the PD. And how do these instruments communicate? How does the source know there is a consumer the other side? So this will also be explained a little bit later. Where is PoE used? A few typical applications you can see here on different power levels, and these power levels are very similar to the standards which are in the background used. So what did it start up? It started up with simple power supply for example these access points, the easy simple access points, or some biometric access control. So terminal units which actually don't need too much power to operate. You see this power which was supplied on the first definition of PoE was these 15.4 watts at the terminal equipment. Then the standard increased, the standard drove up the power, and the next level was 30 watts of power. And now you can see you can do even more complicated instrumentation at the end. You have these IP cameras, for example, with PTC function. So means pan, tilt, and zoom functions. So they will draw, they have motors built in, so they draw really current. Then IP video phones, we typically see nowadays in modern communication systems, and some other bits and pieces. Not sufficient, so the next evolution of these PoE standards went up to 60 watts to 90 watts. That's the definition for these latest and greatest PoE. And now we can also have more communication products at the end connected, like laptop computers. We can power supply laptop computers to charge the batteries. We have these new sophisticated access points like the 802.11 AC instruments, and also cameras, again, very famous cameras to drive the data cable. So also cameras now with heatings in the outside environment, where in the winter time you have to heat up the camera to work properly. As I mentioned, the standards go up to 90 watts. There is also a certain world that goes up HD-based T to 100 watts. So this is the high power environment for PoE, and this also is defined for supplying desktop computers, television, video conferencing stuff, really equipment which needs a lot of power, and also lighting is nowadays a very important application. It gets more and more important. Okay, these are the typical implications where PoE is nowadays used. Right. So what device types and what operating modes are used now? Let's have a look to the device types first. So as I said, we have in general we have two instruments which are taking part on the PoE. One is the energy supplier, which is called the power sourcing equipment, PSE. The power sourcing equipment is a device such as a network switch that supplies power over the Ethernet cable. That's the modern way of doing PoE. If the device is a switch that is a bit older, let's say, there is also a way to combine these existing switch, which has no capability to supply power, to combine with an external PoE injector, and those setup is called a mid-span setup, but we see on the next slide a little picture on that. So what's on the other side or the end of the line, there is the powered device, which is the energy consumer. The power device is powered by the PSE and consume the energy which is supplied. Typical instruments doing PoE are the access points, is IP phones, IP cameras, basically instruments or products, devices which are not moved to very often, and there is no need to have a flexible cabling as well. And what's nowadays also very popular is, of course, lighting. No high voltage lighting anymore, but PoE driven lighting anymore. A lot of these power supply units have also auxiliary power connections for an external power supply. If something goes wrong with the PoE, you can still operate the instruments. Depending on the PoE design, but none or all of the power can be supplied through the auxiliary port. So that's some fallback situation a lot of these end devices have, but this is it's not the rule that the power reason it doesn't work anymore. So let's have again a look to these end span and mid span definitions. So there are two types of PSE devices which are actually used. So the end span devices, which we simply call the PoE switches, or Ethernet switches that include the power Ethernet transmission circuitry already. So you don't need an external instrument to get current and power supply onto the data line. And they're usually used nowadays if you're planning an installation which is utilizing PoE, then you just buy these new switches and operate them. The mid-span devices are these PoE injectors which are placed between a normal Ethernet, so without any power supply Ethernet switch, and the terminal device to be supplied and fed power over affecting data without affecting data transmission. That's also very important, so that these two supply types, the power and the data, are not disturbing each other. So that's important. Mid-span devices are used when no replacement or configuration of a new Ethernet switch is desired. So if you have only one or two lines, one or two access points or cameras you're just adding to your cabling, you would not exchange the complete switch against the PoE switch. You're just adding some external power injector, and use it as a mid-span device. Okay, so mid-span devices can really be simple power injectors, single channel power injectors, or really these, what you see in the picture above, some 90-inch rack devices supplying power to all the channels of the switch in the background. So as I said earlier, there are different techniques to supply the power, and we are sharing the data lines. Usually on modern data cabling, we have 4 pairs for data transmission. And these 4 pairs we can now use also for power distribution. And there's called the alternative A, or the mode A, which is doing a data communication on the same pairs, same two wire pairs as the power supply will be. So these definitions of these mode A and B more or less stems from the times where we were working with 10 megabits or 100 megabits Ethernet, where we didn't use always 4 pairs of wires. So if you remember the old days where we used fast Ethernet, we only used cables or used only 2 pairs in a cable. So these 2 pairs, 1, 2, 3, 6, were used for data communication. And if you also want to drive the terminal unit on the other side, you also have to use the same cables for the power supply as well. And this is called the mode A. There's a little idea to help on this. If you take the A and call it all, you know that this is data plus power supply. So that's a little help on this. What is mode B? Mode B is taking into consideration that you always have 4 pairs available. And if you still transmit fast Ethernet, 100 megabit Ethernet, you're only using pair 1, 2, and 3, 6 for the data transmission. And so you've got 2 spare pairs, 4, 5, and 7, 8. And then you're running your power over Ethernet through the 4, 5, and 7, 8 pairs, the unused pairs. That's mode B called. But you have to have definitely 4 pairs of wires. Since gigabit Ethernet appeared, we always need 4 pairs of data lines. And if you want now to do a power supply onto the terminal device, you can freely choose between the mode A and mode B. So where do you supply on the 1, 2, 3, 6 or 4, 5 or 7, 8? So that's your choice, let's say it this way. This was the definition in the first standards for PoE, where it was sufficient to use just 2 pairs of the data cable to do the power transmission. In the meantime, the requirements have grown, and what we now see latest standards are giving to us is we need more power at the ends. We're trying to power now lighting. We are powering now very high energy consuming access points or cameras, outdoor cameras, and so on. So now what we are doing is we need more lines for the power, and what the latest standard gives us is now a system that uses all 4 pairs to do powering. It's simply a combination of the mode A and the mode B. So what you see when you do an Ethernet and combine it with this way of doing the power supply is you have 4 pairs carrying data and carrying energy at the same time. And there are 2 different types of terminal devices, power devices that can be supplied through that method. And the one is the dual signature PDs, and the other one is the single signature PDs power devices. So a dual signature PD is separating these A and B supply and on its input, and is, for example, can take one part of the energy supply to drive the control circuits, and maybe can take the other circuitry with a different power level, for example, to drive the heating in a camera. So the intelligence sits in the remote unit, in the terminal unit, to use 2 different channels, let's say, of power supply. If you have a single signature power device, it's a bit different. It's also taking the power from all the 4 pairs, but will end up in a single power supply part on the end device. So this is for the lighting, for example, where you don't have too many control units or things like that, where you just want to power the remote device. So that's possible since we are combining here in this 4 pair way, we are combining the mode A and B, but have still a possibility to keep it separate. Where is all these things documented? Of course, they're documented in standardization, in standards. So let's have a look at the standards here in the background. And the standards which is defining the 3 development stages on the PoE standards are, it's the IEEE 8.2.3AF, AT, and BT. You see the different years when these standards were published and the different limits they had. So the first standard was just standard went up to 15 watts at the PSE, at the power supply, which resulted in about 13 watts at the power device. This was not enough for the newer devices, which needed more power. So in 2009, the AT standard came to market, which doubled the power more or less, and so we received about 30 watts at the remote unit, at the PSE, at the supply unit. On the end unit, on the power device, we are getting 25.5 watts out of it. So in the BT standard in 2018, which takes a while to get the standard to life, we are going up now to 90 watts. That's this real high power. 90 watts from the PSE, and resulting in about a little bit more than 70 watts of the power device. Where do we lose the 20 watts? We lose it on the cabling. 20 watts on the cabling can have very hard effects on the cabling itself, but we see later in the presentation. What's the basic principle which is defined in the standardization? It's the power is transmitted in common mode via two or more of the differential wire pairs to the universal cabling. That's the idea behind it, but we already saw this on this event before. So let's have a little look into the standards, and the next slide is just a try to combine a lot of numbers in one chart. So what you see here is a general principle of PoE. The PoE itself is defined in several power classes. They are going now from 0, 1, 2, 3 up to the power class 8. And the power classes are related to maximum power on the one side, on the PSE side, and on the other side, the maximum power you can get on the powered devices. Also, there are 4 different types of PoE, which has to do with the communication in the background between the PSE and the PD. So these 4 ways of communicating and using 2 or 4 pairs are defined in those standards. So what's important when a PSE wants to talk to a powered device, it's important that all of these standardization is compatible with each other. And the ways how to get the communication established has to follow and has to meet all these evolution steps of the standards itself. So you see the first standard, the AF standards, had 4 power classes, 0 to 3. The BT extended it to 30 watts. Class 4 was introduced, and the newer standards, the BT standard, is moving up to 45 to 90 watts. So that's class 5 to 8, and also the types have been raised up from type 1 to 3 to type 4. So we will see this a little bit later where this jumps in. We also introduced the dual signature power devices, which are powered in 4 pairs, and dual signature means you can have different power, on the 2 power channels you have. Okay, a few more details about the background of these settings. So you see the output voltage is defined in the standards and is varying. And you see the input voltage range, which ends up at the powered device, and the maximum current which is drawn. And you see on the BT standard on the very right side, you see we have about 2 amps of power which are on our data lines. This has definitely some effects on the power on the data cable which we're using. So all the resistance, maximum resistance values are defined, and this is also part of the measurement. When you measure a data link, you're also including the DC resistance values, and the DC resistance has to be very low, except otherwise you are heating up your cable. This is something you don't want. So supported operating modes, you see the A and B mode and the combined mode we saw earlier. And the more sophisticated the standards get, the more sophisticated all the power management gets. And we also introduce not only passive communication, which is the startup of the PoE transmission, we also include now active data communication to fine-tune the power given from the PSE to the requirements of the PD. So it's getting more complex. But today it's not time to go into this very detail of this PoE. We want to see the effects more. It's more important for us. So when we connect now 2 instruments, PoE instruments together, on the one side you get the PSE, on the other side you get the PD. There is an activation process, a communication process between the 2 instruments. So how does this work? It's the instruments are not powered yet, so the remote unit is not powered yet, the terminal unit. How to get some information that this instrument needs power from a PSE, and therefore they're using a resistive power directory method to control that activation process. So, and the PD must have some basic passive properties, resistance properties, to be recognized as a powered device, as a PoE supporting device. And the typical steps of the activation are, the first step is the detection. So the PSE recognizes a certain range of input resistance on the powered device. And this triggers the PSE to see, there is a PD on the other side. Then they're starting to check the connections between, do we have a 4-pair or 2-pair configuration? If it's a 4-pair configuration between us, so are you a single or are you a dual signature PD? So that's communicated between the two instruments. And then the actual classification process is starting. So classification means it's a special procedure where some signals they define signals are sent between the two instruments to determine the exact resistance value and to combine this, to map this to the determined power class, the needed power class of the remote device. We see this on the next slide, how this communication works. It's a passive process, it works. If the two instruments have agreed on the power class they want to work together, then the startup, the inrush procedure is started, and this is the controlled activation of the power supply. So it's starting up the power device in a very controlled way, not to break anything on the circuits. So operations. So the power supply is always monitoring and is giving also a fixed power supply to the PD to allow continuous operation. During all this time when the PSE is powering the PD, there is also power management in the background, which is always activated. And it's, first of all, the first steps are some fine-tuning between the PSE and the PD using some link layer definition protocols, so active protocols, which are more fine-tuning between the steps, maybe between the classes. Then a permanent monitoring of the power consumption is taken, which is very important. So if in the worst case, the camera is getting some short circuits internally, it should not break the PSE and not overload the PSE. So a permanent monitoring is important between the two instruments. And if to turn off the remote, the terminal instrument, also there is a switching process defined, and the monitoring also has, the power management also has to monitor the moment when the remote part of the end instrument is going down, is switched off. Okay, on the next slide, as I said, you see this process, and you see it's a very detailed classification procedure between the two instruments, between the PSE, and it's also defined for the different types of PoE which are existing. And you see there is a voltage, and this voltage from the PSE is converted into some current due to the input resistance on the PD, and depending on the current which is drawn, the instruments start a kind of a communication process which leads up into a classification, and the number of pulses used are tied into the type of the PoE. So the older types using 2 of these pulses, the newer types of PoE using different types, different number of types, because they have to support different more classes and so on. So this is kind of this is the classification procedure between the two instruments. Okay, but I don't want to go into that details. So what's more important for us is now the implementation of these PoE stuff. Implementation, what do we take care of? Do we have to take care of the cables, about the bundling of the cables? As I said earlier, we are talking now about 2 amps of current on the data cable with an AWG 23 diameter. So this can raise some trouble, some problems. So let's see. There are also standards which are taking care of these issues. And there are 2 famous standards which are used when you are designing a system which is PoE driven. And the standards are the ISO IC Technical Report 29125, which was the standard representation. And for the American market, it's the TIA TSB 1848. And what you find in those standards is the requirements for information technology cabling, for the power supply of terminal equipment. So it's the definition how to bring these PoE ideas onto cabling. And there are tables you find in this which gives you heating effects. So the most problem we see when we drive current over the cables is that there's heating effects. And if heating we don't like in data communication, because if we heat up our cables, the attenuation of the cables is dramatically going up at certain temperature ranges, and this can stop data communication on certain lengths of links. So we have to be very careful about the heating effects when we drive also current on our data cables. So as you see these tables here and these graphs above, this is defining how the effects of PoE on the heating of the cables, and they give you some hints about, the standard gives you hints what to do, how to construct a bundle of cable, how many cables in a bundles are allowed to avoid any trouble with the heating effects of the PoE stuff in the background. So these are very important to be recognized when you're setting up a system PoE driven. So PoE interaction with cabling. So as I said earlier, we are driving up to 2 amps direct current. That's heating up the story. And what is also influencing these heating effects is, of course, the diameter of the cables. So usually we are very used in the past to use AWG 22 and 23 cables. So now the recommendation is stick to the AWG 22 cables. There are also tendencies to use thinner cables, but if you use thinner cables and for less space when you bundle it, you also have to make sure when you plan to use thinner cables than AW23, you have to have distance between the cables to get the cooling between the cables, and that's also an issue. So be careful with the diameter of the cables and the PoE you want to use on this. Bundle size, of course, don't bundle too many cables. Spacing between the cables is definitely important to allow the heat to disappear. Type and design of cable routing. Is it good to have it in a closed duct, or is it better to run it open? Shielding or no shielding. So we are here in Germany. We're used to shielding cables. Shielding cables help us to get rid of the heat definitely easier than in unshielded environments. That's important. What will be the consequences of excess heating? Of course, high power loss, attenuation values are really increasing. Excessive increase in insertion losses out here, and the risk of heat damages. So if you see that we can burn on a cable about 20 watts, if we have 10 cables, we have about 200 watts. 100 cables, a bundle of 100 cables, is 2000 watts of heating we have to get rid of. This can also have certain damages, definitely, to the heating effect. So not only the cables heat up, temperatures in plugs and sockets are influenced by contact resistances. That's also a complex topic. Usually when you connect or disconnect the data communication cable from a patch cord from the outlet, you should make sure before that the PoE is deactivated, so the remote unit is turned off. That's the theory behind it. In practice, in the real world, people just take out the patch cords. And if you take out the patch cord, you can see what you see in the middle of the pictures here is you're burning, definitely burn up the contacts. So, and if you see these contacts are burned and the data communication is not working anymore. So make sure when you buy components which should be used for PoE applications, that in a RJ45 check, the contact point for the first contact with the connector, with the plug, is a different one, a different location as the one which is driving the data later on. Otherwise, if the contact point for the electric contact and the data communication is the same, and you have these kind of burn-ups in the contacts, the data communication will die as well. So make sure that you define components which are separating between the electrical contact point, the first contact point, and the data transmission point. What else can cause trouble? Of course, as always, poor craftsmanship and terminating the cables, and this can be caused by using of unsuitable tools, termination tools, the wrong ones. You sometimes see that nice water pump pliers are used instead of parallel pliers. So You see mechanical trouble you can generate yourself, which is causing resistance, and you don't get proper contact between the contacts and the wires, so that's a trouble. And each contact point is creating resistance. Extra resistance means extra heating and can destroy the communication link. Mode of operation, non-compliance with manufacturer's instructions. Yes, sometimes cheap instruments don't follow the standard rules and cause the system to get crazy. So same story as always, buy only stuff from named suppliers which supply good quality as well. So what's general rules to ensure smooth operation of PoE, that it works loss-free and without interference of the data channel? So first of all, the passive cabling must not have any interference. So the most important parameter when we're talking about power over Ethernet is DC resistance, all parameters around DC resistance, and any possible DC resistance unbalances between or within the individual wire pairs. That's important. So the DC performance of the cabling is definitely one of the most important factors to influence this proper operation. The installed material must comply with the relevant component standards, very important. As mentioned earlier, don't buy cheap crap. You run into real trouble when nowadays using with high power PoE. Termination process must be carried out according to the manufacturer instruction. That's another story. Don't invite your own way of doing combinations of plugs and components and cables and so on. Follow the instructions to make sure that everything works properly. And what's very important is when your passive cabling is finished, do inspection and documentation with a certification device. Use a proper certifier to do the testing of the electrical performance. Next story is on the active side, the active components like the PSCs must be able to communicate with the PDs and provide sufficient power. That's also important. Make sure that that the switch you want to use is really fitting to the application you want to use, to the end devices, the power devices. Make sure that it's really complying to the activation steps standardized in the standards, and not some cheap one which is not following the standards. So the activation process might not work and you have no idea why it's not working. Sufficient power available to the required switch ports. That's also a point. Sometimes people get a little bit confused. So because switches take certain amount of power and this give it our PoE to the remote devices, to the terminal devices, but sometimes they don't allow always power reason at full power drawing on all ports. So if you see a certain number of power which can be supplied by the switch, take your calculator and see whether this is really sufficient and look if every port is really supplying PoE at the proper levels. So sometimes switches do not supplying all the ports with the proper power you need on the remote devices. And you see when you do a calculation on the available power, you'll see that you only can maybe drive 2 switch ports to full power and the rest doesn't work anymore properly. So that's important when you plan to purchase active devices. When you do testing, you can test these ports, of course. Make sure that you're doing a load test, not only a voltage test. So that's important because sometimes you see, especially when you have switches which do not supply enough power on all ports, and you see that the voltage is there, but if you don't load that port, you don't see that the power, the current is not properly supplied. And so finally, inspection and documentation again with a modern cabling tester or a qualifier. So this means to document, is this port which is connected to the switch port, is it really capable to supply me the power I definitely need now? Okay, so let's have a closer look at this passive stuff, to the passive cabling. So when you're talking about high power PoE, which goes up to the higher ranges, 60 to 90 watts, we definitely have to make sure that the resistance performance of the transmission path is absolutely fine working and has no too high values of resistance on the connection points or on the line itself. So far, it's always important. It was always important to have a low resistance, a low DC resistance, which was very important for not losing any information. And but nowadays we have to test a little bit more and a little bit deeper. So in the past, it was fine enough just to do a DC loop resistance test, which is also sufficient if you go up on the lower levels of the PoE, and you go up to 15 watts or 30 watts, so the first standards existing, that was sufficient. But nowadays, when we go up to the BT range, to the 60 to 90 watt range, we have to make sure that also the unbalances between the pairs and within the pair are fine working. So first of all, we have to make sure that we're talking about the same definition of cabling. When we are talking about cabling used for PoE, we are talking about the cables itself, we are talking about the connected outlets, and the patch cords later on used for the system itself to connect the end devices into this. So nowadays, measurement of DC loop resistance is not sufficient. We have to do some additional measurements when we know that we are going up to high power PoE. So we also have to define or measure the DC resistance unbalance between the pairs to make sure that this is not too much above. The DC resistance unbalance within a pair, even on the individual cables of a transmission line. So, and there are also standards in the background which are clearly defining to what limits we have to do those measurements. So, and if you do DC loop measure resistance and resistance unbalance measurements, I'm using again these the typical standards as we have the ISO IEC 11801 and the American TIA 568, the standards for cabling. And here are the values they're giving us for a channel link. Channel link, I like to use the complete link because it's also including already the patch cords, which can be a really affecting part of the performance of these links. So the channel link is allowed to have a resistance value that is smaller, lower than 25 ohms. That's the standard, which was always in the standards. So, but now we have added these unbalanced limits, and so between the pairs, we are allowing a maximum unbalance now of 7%. This is the minimum value here is 200 milliohms, and even within a pair, we are down to 3% difference between the pairs. So it's very, very well defined now to make sure that the PoE, the high power PoE, is working without any trouble. Okay, if we would exceed these individual limit values, what would happen? So on the DC loop resistance, of course, we get high power dissipation. If we lose too much power on the cables, the heating is going up, even into dangerous regions. And what I mentioned earlier is the increased attenuation, insertion loss values, which are stopping longer cables from working properly because you lose all the energy on the way already, on the path already. The DC resistance unbalance exceeding the limits would have other effects as well, like transformer saturation. So you're modifying distortion of the waveform is a consequence. You're getting modified waveforms. You don't get the bits anymore properly sensed. So, and this causes bit errors. So unbalanced DC unbalanced cable can be the reason why data transmission doesn't work anymore. So very, very dangerous thing. So in a 4-paired PoE system, a certain unbalance is allowed and can be tolerated, but if it's too large, PoE will not work properly anymore. So make sure that these values, the DC performance values, are properly maintained. So these are samples from the standards where this is mentioned. So and we have to see to differentiate between the international standard and the American standard. So in the American standard, the DC current resistance unbalance, and in the international standards, these parameters are optional because they're not needed if you know that we are doing no PoE or doing only low power PoE. If you know that you are doing high power PoE, the ISO and the IN is driving this to normative, so you have to do the test, you have to do the measurement. The DC loop resistance is normative. The Americans never really were interested in DC loop currents, DC loop resistance, but nowadays to this PoE stuff, it's also taken into the on board of the standard. And as I said, DC current resistance unbalance is optional. Optional in the standard means it's if you activate the measurement and it's passing, it's okay. If it's failing, the whole test is failing. There is also another letter which is used in standards that's called I for informative. Informative there's no effect on pass or fail. But if you do activate an optional parameter like diesel resistance unbalance and it's failing, the whole test is failing. So it's different of the different methods used in the standards. So now let's have a real life example. So what you see here is measurement screens from the wire expert from our certifying product. And you see that we have activated now, for this test, we have activated the resistance and the DC resistance, DCRU performance measurements. And you see the summary screen and you see the detailed screen for the different parameters. You see the 3 tabs on top where we can switch between the loop resistance and between the resistance P2P compared to pair, between pair to pair, and you see the unbalance within a pair. So these measurements, the 2 right ones are the new ones added now to the instruments, also using special testing measurement adapters. And it's also taken on board of the certificate. You see at the very right side. So that's the measurement you have to do with the wire expert, the certifying product. Okay, if we pass this, we move on to the active testing. Active testing, what does this mean? Active testing is simply testing, does the activation process work? So we're using for these active testing, typically either we use a verifier or a qualifier. On the picture here, you see the NetExpert, our qualifier product, and the CableMaster 800 as a representative of the verifier product range. And what these instruments doing when testing, they're simulating to be standard power devices. They are checking the activation procedure as we explained earlier, and then they determine certain parameters and showing and storing the parameters, what's offering on these power supply, what mode is used, up to what power class we can operate. And we're also checking the load conditions, so to see can these ports really perform properly to the highest value of load we have to this. And that works, of course, for a standard switch with PoE or a switch without PoE, where just the PoE injector is in the middle. These are the results then. This is the screens you get and the protocols you get. You see all this information which is in this testing screen. You see the ports capabilities, what speed is supported by those ports. You see some signal to noise ratio margins, and you see how many watts is drawn. This is not the latest picture I just realized. So the latest picture is also converting the power, which is seen, into the class number. That's an addition now we have done. It's also the protocol, the NetExpert series. On the CableMaster series, you see the screen you get. So it's also checking the link capabilities and to a connection. It's also very important. It's loading the port to see up to what maximum load this port will operate. I think that's it, basically. Yep. Thank you very much for the listening. I seriously apologize for these inconvenience we had with the techniques, with the audio stuff here. And I think this is the point where I ask Arda to come close to me, and I'm activating the camera again on stage and answering the questions which turned up in the meantime.
Okay. Sure, we've got some questions. So starting with the first one, does a modern switch have backwards PoE compatibility?
Yes, yes, yes. You have seen you have these 8 classes. If you have a modern switch that goes up to class 8, it's also supplying the lower classes. The communication process will work with every PD. It's pretty much very nicely standardized.
Mm-hmm. So the second question is, in which standards the bundling defined? Exactly.
ISO, EAC, TR 61215, was it? And and the tire is the 184 standard. So these are the 2 standards which are defining the bundling.
All right.
Yes, and how to bring such a system into reality.
Mm-hmm. Another question. Can I do measurements over a PoE injector? Will it work?
With a certifier?
Yeah.
Yes, you can do the measurements, but you have to be a little bit careful. If the mid-span is in between this line you're testing, when a certifier is doing its wireman testing, it's switching lines together and it's doing shortening and sees all lines open. This can have influence on the mid-span device and can shorten the midspan device and can ruin either the device or the test instrument. So in the wire expert, there is a switch you can activate that there is a midspan device in your communication path. And it's then deactivating this DC wire map test and does a simplified AC wire map test, not to risk any damage of the midspan device and the certifier and or the certifier.
Well, we have one a longer question. So I'm just reading that out. Can you explain once again about plugging and unplugging PoE devices and how to avoid contacts getting burned? I have plugged and unplugged loads of access points driven by PoE without following any special procedure. How should you do it?
It's simple. The official way is just to deactivate the PoE. You can do it on the switch. You can turn it off from the switch. If you can't turn it off from the device, from the power device, and then you unplug it carefully. That's the classical way you have to do it. Yeah. So make sure that there's no PoE activated at the moment. If you see the burn-up on the higher PoE classes, make sure that you have really good components with different location for the contact points.
So I hope that answered your question. Seems like we do not have any other questions. That was it for today.
Okay, I think I have still one for the housekeeping. Oh, yes. Okay, this presentation you just saw and some product information we have put onto the download area of the GoToWebinar. So you can download that here, and it's free of any voices. And we also record this here and cut little things out, and you also get a link to these presentation as well.
Yes.
The recording of this presentation.
Yes, and if you have further questions, you can always email us, ask your questions, and we'll be happy to answer them.
Absolutely, absolutely. Okay, fine. You're done?
Yeah, that's
okay.
it.
Thank you very much for listening. Again, sorry for the little technical hiccups, and see you soon again.
Thank
Stay
you.
tuned. Bye.
Bye.